Welcome. In this module, I'll look at how cluster users can interact with Platform HPC to run and manage application workloads. Platform HPC takes the complexity out of running and managing applications. I select the Jobs tab to view and manage applications and data. From this view, users have access to their jobs, all job-related data, as well as several useful reports. Users normally see only their own jobs, but administrators see all activity on the cluster. I'll select a running CFX job. CFX is a popular commercial computational fluid dynamics application. With a job selected, I can do things like suspend, resume, kill, or requeue running jobs. I can also view job output in real time through the browser. A job notification feature built into Platform HPC lets me know when a job changes state. I'll open the notification window. Notifications are helpful for long-running jobs. They make us aware when jobs are complete so we can examine results and immediately move on to the next task. They're also useful for detecting exceptions, like jobs that exit prematurely. I'll close the job notification window. When I select a job in the top panel, detailed information about the job appears below. I'll make the lower panel larger. From here, I can monitor the job status and view or manipulate files as the job runs. I can also gather additional detail about the job. I see information like resources used, job priorities, and even the process IDs that comprise the running job on the host operating systems. I also see the job command line, the project the job is associated with, and the queue in the workload management system that the job was submitted to. For sites running many jobs, it's handy to be able to filter to quickly find jobs of interest. I can find jobs by name, ID, queue, job state, or user. To make running applications easy for cluster users, Platform HPC provides tailorable application interfaces called job submission forms. I'll select Submission Forms from the Jobs tab. I can have a practically unlimited number of applications, but as a cluster user, I only see application forms that have been published and made ready for use. I'll show how we can create and publish these customizable forms in a minute. I'll submit an ANSYS job, an application used for a wide variety of engineering simulations. The ANSYS form only asks me the details needed to run an ANSYS job, and these will already be familiar to ANSYS users. If I use ANSYS regularly, I can customize this form further, providing my own default values. This speeds data entry on complicated forms and reduces the chance of errors. Submitting jobs with errors can be wasteful of resources because often errors are not detected until a job's run to completion. I'll fill in the form that describes my ANSYS simulation. I'll run ANSYS as a distributed MPI job on 2 CPUs. Platform HPC has Platform MPI pre-integrated. Our application template hides all the details of running ANSYS with MPI. It does this automatically. Platform HPC supports other MPIs as well, but Platform MPI exhibits better scalability and has the advantage that applications don't need to be recompiled to use different types of interconnects. I'll select an ANSYS input file that I already have on the server. Manipulating files like this directly on the server is useful when datasets are large. I can navigate through files on the server and even share files with other members of my project team. I have a small ANSYS model here that comes with the ANSYS software distribution. With the file selected, I'm ready to submit the simulation. The job is now pending, waiting for 2 suitable machines with ANSYS and MPI installed to become available. Notice how users are insulated from all the details like worrying about operating systems and MPI versions. All these details are built into the application template. While I'm waiting for the job to be scheduled, I'll show how I can view files on the server. The input file has been moved to the working directory. This is where all files associated with the simulation reside. I'm looking at the ANSYS input model, but I can view any other files in the same way. This job will take some time to be scheduled because we have a small cluster and there's other jobs in the queue ahead of us. While we're waiting, I'll show how administrators can customize these application submission forms. I'll select the Resources tab. Platform HPC comes with a library of built-in templates predefined for popular applications. Customers can create their own interfaces as well, using the provided templates as examples. I'll modify an unpublished submission form for Schlumberger Eclipse, an application widely used in the oil and gas industry for reservoir simulation. A form builder built into Platform HPC makes it easy to customize these user-friendly forms. Each field on the form has a unique identifier. Values selected by a form user become available in a job submission script associated with each form. I can easily add, remove, or reorder fields using a drag-and-drop interface builder. In this form, I'm allowing the Eclipse user to select their preferred version of MPI. I'll edit this field to show how fields like this are defined. I'm allowing users to choose between Intel MPI and Platform MPI by providing a custom list of selection options. Customers can create their own scripts that provide selectable values at runtime, perhaps by checking the server environment or doing a database lookup to retrieve information like valid project identifiers. I'll show the submission script that is paired with the Eclipse application interface. Cluster administrators can easily adapt existing shell scripts and make them easy to launch and manage through the web interface. Managing scripts this way eliminates a major headache. Applications can be integrated in a standard way and based on a standard framework. This makes scripts easier to maintain as they evolve over time. The actual command that submits jobs to the cluster takes arguments that depend on how the user filled in the web-based form. Most Platform HPC users don't need to worry about this level of detail, of course, but this approach to integrating applications provides flexibility. Viewers interested in learning more about building application interfaces may want to watch a separate Platform Application Center demonstration. I'll select the Jobs tab again. Now we're back where we were earlier, monitoring jobs. A nice feature of Platform HPC is that I can monitor jobs at the same time as I submit new jobs. This is useful if I want to copy input parameters for another job that's pending, running, or already completed. I'll use a generic form to illustrate how this works. Notice how the side panel expands, showing the jobs view and submission form side by side. I'll widen the form. The application interfaces are essentially self-documenting. Users can submit jobs to Platform HPC clusters comprised of Linux or Windows hosts without needing to be knowledgeable about all the details of the environment. I'll close this form. Before I wrap up, let's take a quick look at reporting. I'll select Job Reports in the Jobs tab. Platform HPC includes several useful reports. I'll run an hourly job throughput report showing a summary of job activity on the cluster. I'll look at activity over the last 2 days. And I'll produce the report. And a chart is produced for me. The underlying data can be exported to CSV format for further analysis. I hope you've enjoyed this quick tour. Let's recap some of the key features of Platform HPC related to running and managing applications. Platform HPC provides user-friendly workload management. With virtually no training, users can be productive immediately submitting and managing their own jobs. With a library of application templates for popular commercial and open source applications, applications are easy to integrate. By using application-specific forms, users are made more productive, error rates are reduced, and training and support requirements are minimized. The drag-and-drop interface builder and editor makes the forms easy to customize. With only basic scripting skills, users can adapt their own applications to the web-based environment. Finally, Platform HPC includes a robust commercial-grade MPI. Users enjoy better performance and more flexibility, and because MPI support is built into provided templates, parallel applications are made easier to deploy, manage, and support. I hope you've enjoyed this overview of Platform HPC. Thank you for your time.